Yeah, let's go. Oh, let me bring Volcano
All right,
here.
you're live just as we're getting Volcano up and running. Welcome, everybody. We'll be going over Volcano today with Carlos. As we're setting it up, say hi in the chat. And I'm going to go ahead and dip out if you need me, Carlos. And I'll be seeing the rest of you in chat. All right.
Yeah,
Good luck.
thank you so much. Do we have people join? This is live, so you're not watching live, you're watching on YouTube. Um, so go ahead and say hi in the chat if you're in the LinkedIn or YouTube. I think those are the two places we are streaming. So we know we have folks joining us every week on Thursdays, 3 p.m. here in the Eastern time zone at noon PST. And what we do in the crash loopback chat loopback of the CNCF is we pick a different CNCF project, uh, and then we take a look of like how to get started, what it is, why is it useful, where to find information, and just enough for you to be aware of that. Because right, what I have here in front of me is the CNCF landscape, and there are many projects in the landscape, but the CNCF projects are a little bit less than that. And I always try to show people how to navigate this. So if we can also filter by CNCF projects. So this list should reduce. See, you see, it can reduce. So we have Cilium there, CNCF project, Adapter, and then today what we're going to be looking at is Volcano. I was given, and what we do is we try not to tell the hosts, like myself and other CNCF ambassador or people from the community that help do the streams, is not much time in advance of what is the project that we're looking at, so we can give you like, kind of like a real experience on how this works, and also feedback to the CNCF project on if they need to improve anything in the getting started documentation or missing a few things for people that just want to get started and maybe they find some roadblocks. So we'll find those roadblocks if any, probably not. So Volcano is the project. It was sandbox in 2020, April 9, and it became incubating in 2022 in March. And in CNCF, those are like the three stages of a CNCF project to get graduated. In this here views, you can get like how active is the project and such. Actually, I was looking at the TOC proposal. It had a lot of information. Maybe look at that. But yeah, from here, I think you can jump to the website. Let me see if I have the website. Yeah, we usually put the website, the GitHub link, and other aspects. So if we link here, we go to Volcano. And Volcano is a cloud native batch scheduling system for compute intensive workload. Um, I believe the founders are from Huawei and other ones. So let me look at the TOC. I was looking just for these new projects. I try to look up like who's behind it. The proposal usually has good information. So if you look for the CNCF TOC, let me see if I can find the link. Technical Oversight Committee. So this is the committee where all these projects go through when they are sandbox, incubating, graduating. And if you look in the proposals, you should be able to see that Volcano was submitted, and then you will see the file here. But they're incubation, so the incubation should have more information, recent information. So if we go in here to look for Volcano, they have a file here. So probably we'll include some of these links in the description in the YouTube, so you don't have to look for them now. But the latest release at this time was 1.3. Right now it's 1.9. But you can see here the features that they offer, right? So it's a powerful support to mainstream compute architecture such as Spark, Flink, TensorFlow, and PyTorch. So Volcano sits below these type of frameworks. Um, and then these frameworks basically leverage Volcano CRDs or Kubernetes CRDs. They also provide the reasons. One of the reasons they depend on Volcano is because Volcano is the one that implements advanced scheduling for batch. So some of the schedulings are like gang scheduling, backfill, bin pack. Gang scheduling, I don't really like the name. It's not a very like positive name, but it's a scheduling mechanism that it says if I'm going to launch 100 pods and they have to be up and running at the same time to synchronize some type of compute across all of them. You don't want to one start before the other ones. Then Volcano is a perfect project for that. They also can mix scheduling heterogeneous resources, like basically how much memory would this work job or queue, how much memory CPU resources it needs, or what's the maximum. Like I don't want this queue to take more of this amount of CPU memory at one time, so it will like schedule uh, the pods as it needs more, as a memory and CPU is available. It will schedule the other ones. Let me see what else is here. It supports GPU sharing, which is one of the practices today that are used for machine learning model training. Or inference also to share GPUs. So GPUs have the capability of being shared, but to configure that in the container space, like something like Container D or Docker, and then on top of that with Kubernetes, there's a certain way that you have to configure those, and Volcano is one of the things that can support that. Let me see. So I was looking for like the companies behind it. So, and these companies usually they're behind it because they have products in production running this software. So Huawei Cloud has is using Volcano as a scheduler for one of their services. Tencent is using Volcano as part of the infrastructure at the Department of AI Computing, and you have other companies, right, using Volcano in production, even for financial. I think I saw financial here. I see some questions coming in. It says, "Hey guys, yeah, put it up. Hey guys, I was reading about Volcano just after finding in the CNC and Alaska's mapping. Considering the current times, workloads are for sure becoming more effective in AI, but I'm old school guy, so I'm thinking about it also for ETLs. Yeah, batch pods. So we'll see in a minute. Like it's basically the construct is a job. So basically, you can create jobs with ETLs, right? Um, or you can use jobs to build ETLs, pipelines versus distributed compute. So thank you for your comment. Very good. And yeah, no one is old school guy. I'm also an old school guy. So Linux kernels, RPMs, compiling drivers. Yeah, I don't know if you call that old school. The roadmap is here. This is an old roadmap, but in their repo they have uh, more up to date. Maybe that's something that they need to look into. I was looking at the roadmap, and is more updated than the that one, but I think at the bottom they go up to 2020 2022. So version 1.6. Version 1.9 is the latest one, so probably they need to update this. So this is nothing bad against the project. It's just this type of things is something that maintainers in CNCF projects, if they don't have a lot of people right to help with this, they're not keeping up. But this is where the opportunity is for people that want to contribute to CNCF. So a lot of people, probably to Jorge also, like ask us all the time in KubeCon and also like in events, like how do I contribute to CNCF? And I think some people take it as lame of like helping with documentation. But documentation is a very powerful way of you getting involved in a project. So me as a maintainer, if I'm maintaining a Volcano and I see someone saying, "Hey, can I help with the docs and the roadmap and make it at the recent releases?" and then put in there some of the things being discussed in the meetings, and I take notes. That would be huge contribution, and will be very, very appreciated by a maintainer. And that's how you get involved into a project, because maybe this is a project that you're interested in on collaborating or learning. and potentially maybe use it in your company. So documentation is very good to get involved into a CNCF project. I don't know if people want to comment in the chat if they agree with that, but that it's difficult sometimes to find a specific um, case or use case for a specific project on how you can contribute. But if you find a project useful, get started, start using it, and you will find things like right here. I found one. Right, there might be an issue, and if there's not an issue, maybe we can create one about roadmap. Right. Um, and then you can create an issue here, and then tell the folks that you want to contribute, and you want to contribute documentation on the roadmap. um, but anyway, we were able to find the repo. I think the website, we were looking at the website, so let's take a I like to visit both the website and the repo. We'll look into the repo and then we'll go into the GitHub. um, so Volcano, another scenario where I said like it's good for machine learning, deep learning, bioinformatics, and also for big data. Let me see if it shows the different projects. So yeah, Volcano by itself, it might be useful, but it's a building block. So things like Argo workflows um, can leverage Volcano. So you can create CRDs from Volcano when you are like creating a. So this is a actually who was yeah, I think it was Fabricio was saying like ETLs. So Argo workflows, you can build workflows, ETL workflows with Argo, and then within your like tasks, then you can use a Volcano if you want to do a some processing on a queue, or like use the system or the resources that you have. Maybe it's a shared Kubernetes cluster and you want fairness. So there might be different queues of like top priority jobs that need to run, and then less priority jobs that need to run. But then you're building an ETL that delegates that to Volcano, and then eventually Volcano will schedule your jobs, and then they become pods, right? But you don't have to do that aspect of creating queues and putting jobs in a certain queue, and then limit the amount of resources that they use. So Volcano can do that, and you can build an ETL with Argo. Another one that is popular is Kubeflow to create machine learning kind of pipelines. I think the one that I was playing with was TensorFlow. The other one that I know is popular, maybe they have it I saw it in the docs, is Ray. Yeah, Kubeflow. Ray it's another framework. I think I saw it in there. And probably see that's another example. If you want to contribute to CNCF, right? Start your open source journey. There is integrations here is missing that I know for sure of one that is a very popular project called Ray, and I think this is their GitHub repo. So and this is a better view of that picture. So maybe this is something that they can improve. This picture, I think they have it in the website, but it's not in the main website. So all these frameworks can sit on top of Volcano, or you can just directly call down. But mostly these frameworks will call Volcano, and then Volcano will have a scheduler, the controller, and the CRDs where you create the CRs. And there's not that many. We'll take a look at what they are. I think it's maybe 3: a queue and a job. There's a couple of talks. Some of them are from KubeCon. Again, there's some recent ones. So if you want to contribute to docs, you can find some of those talks in the CNCF YouTube channel, and then add them here to help the maintainers with that. Let me see the integration. I think I was reading the integrations here. Oh, they put the Kubernetes compatibility, so that's very good. I think it goes up to 120 or 130, so that's good. Somebody updated this recently, so that's the latest version of Kubernetes. So if you're in Kubernetes 130, you would need to use head. Um, so it might be that they haven't not tested 1.9 on 130, but it looks like the next release was they want to support 130. But we'll give it a try. I tried 130 and it seems to work. Everything seems to work. Um, I think I was looking for, maybe it was in the different. Yeah, Ray. So it's Ray. They use Ray actually uses Volcano, let me see where they are. So Ray, something with Ray. I think that was the home page. These are the integrations. This is the updates, and then if you jump into these are the companies again. Like, this is very good website in terms of the CNCF, and then every CNCF project should have the logo, and then in indicating what is their level, if it's incubating, graduated, or sandbox. So they pass that. So that's something that in CNCF will make sure that it has that information in the website. Let me go to, let me see, documentation. I think these are the sections. So documentation maybe looks at the latest documentation. Um, and these are the type of scheduling policies that they implement in Volcano. The GAN scheduling that I was mentioning, of waiting all the pods to be ready before, like, start executing. Preemption, scheduling, reclaim, and resource reservation, which is, I think, one of the most popular. Also queuing, scheduling I was describing. Um, the support arm. One of the examples didn't support arm. I think one of the images. That's what I was trying to debug earlier today. The ecosystem. So the ecosystem has multiple things in here, like Argo, PyTorch is very popular, TensorFlow, Open Open MPI, which is if you are doing HPC. Usually, this is the protocol. For example, things like Slurm that you'll be using for communicating and passing that interface of message passing, right? Very popular in HPC applications. So you can also use it for HPC. I think they have an example in their docs. You see what maybe probably Ray. The reason I know they support Ray, because I work on a project called Data on Kubernetes, and we have data on EKS, which is part of Data on Kubernetes, and they have a cool demo that I was planning to set up, but I ran out of time. But maybe I'll record a video that you can, like, train something like super cool is Llama 2, or like one of those meta machine models. Llama is one of, like, there's many popular large language models. So Llama 3 came out, I think it was a week or 2 weeks ago. I think I want to say Llama 3.1. But this is similar aspect of, like, using Ray, and then Ray uses Volcano to do training. So it's using Ray train and Qt Ray to basically start, like, machines are very large in terms of CPU, like maybe 128 CPU um, and GPUs. And Qt Ray, you would use Volcano to do the scheduling. So if we search, I was looking, it uses Volcano, and in this case, it's using the GAN scheduling algorithm to send the jobs for training. So it will do like two types of jobs. Is like to get the data set from Hugging Face, download all that data into the different computes that are going to run in parallel to do the training. So that the training will be distributed across all the machines or all the pods that are running. Usually one pod will take one whole machine, and it will do that. So CubeRay, this is how you create a queue. So it will create a queue in Volcano. In this case, we'll say, like, the capability has like 500 CPUs, right? So you're using big machines, 1500 gigs of memory. So that's the capability. Like, this queue can, like, take this amount, of when you hit this threshold, then it will not take more jobs. You would just put them, will queue them, right? You will not execute them, or that's the maximum that I can execute in at one time. And then the RAID cluster is what creates the executions of the job. And basically, this is the RAID cluster is the one that is going to start creating using the queue. So you have to specify the queue that you created in here, and then start creating jobs Volcano jobs. So that might be, maybe you don't see a lot of examples for the Volcano by itself, because most of the useful examples are like these other frameworks leveraging Volcano. Are there any questions or comments? I think we have, we have Jack from Chicago joining us. We have people from Philadelphia, Shannon. I don't want to put them on the screen, Jorge. Um, but yeah, so hey, say hi, and then that this would encourage you to join live next time. I think we're doing it every week. Um, so let's try to see how we can run this stuff. Like, I just gave you an overview. Like, why would you care about like Volcano, or you hear Volcano in the coffee shop where you live? There's a bunch of Kubernetes nerds like me, and then you approach them, say, "Hey guys, or folks, I want to know more about Volcano." So the way I like to do it is, I think we saw the introduction. Um, we saw the architecture. So the architecture. Hey, let's look at the architecture. So Volcano is composed of a CRD controllers, which is Kubernetes controllers, reconcilers for the CRDs. It's a combination, and then the thing that does the main like work is the scheduler. Um, Volcano has a mission, so it's a like a mission webhook. It has a CLI VCCTL. Um, this is just the CRDs, like I mentioned, is very simple. Like, not simple, like not that many. There's other projects in CNCF that has many CRDs, and you have to like learn how to use them together. This one has three main ones. It's a job, a queue, and a pod group. And then for every CRD, there's a controller manager and with the reconciler that can live in the same pod, same container, or separately. But the way you code the typically in Kubernetes controllers, you have a controller manager for each one. And then we have the Volcano scheduler that actually is the one that is monitoring the execution. I think that's it. I think I explained what was down here. Um, so let's go to installation. Usually it says 1.12, but I think you should watch. I think they should point to the table that we were seeing of like which version should I be using if I have a certain version of Kubernetes. Um, they have a version of like installing it directly here, or they have a version of installing Helm chart, installing from code. This one, I don't know what it does. So let's look at the repo. And then Helm chart. I think that I'm going to use Helm charts easier, but this one should not have that much specific things. So if we go to the repo Volcano, and what was that file? Okay, I got lost. Hack folder. That's not the website I was looking for. Let me close some of the repos that I have. Hack. I don't think it has something like special. It says a local up cluster. This one we use. I think it builds everything. Yeah, this one is for more for development from scratch. The other one, local up Volcano, it does the installation, and again this would have like internal development. It would do a kind cluster, and install.sh. Should we try that one? I didn't try that last time. Let me see, lib install.sh. And yeah, this type of workflows is for people that want to contribute, and it's like building the source code, um, and loading into the kind. I don't know that. I think for people that are getting started, I think the simplest thing is just create a kind cluster and use the Helm chart. That should work out of the box. So let's do that one. I already cloned the repo. I think I have an example with Argo CD. So maybe we show that later. But just to get started, very simple. I think if I clone this thing, let me open it. Oh, that's where I was. And then kind cluster, kind get clusters with an S. There's a kind cluster and it's a local dev. Let me delete. I don't know what I have in my kind cluster, so let me delete the kind cluster. The local dev is another kind cluster that I have. See what I break. So yeah. Oh yeah, I was playing with something. I wanted to play if I have two worker nodes. Usually when you create a kind cluster, you get one worker. But I created a file here. I was playing with these files today. You can specify like this, and then you get three worker nodes. So let's do that. So if I do kind create cluster dash dash, I think it's dash config, and then I can point to, where did I put this? Because the tutorial that they have it's like they don't have a easy way from the docs to have this file. So I was creating the files from scratch. So it's not docs, it's example. Uh, tutorial and then kind. Yeah, let's do that. I'll get 130, but I bet it's going to work. And also that they have the Helm chart in here. Where is it? I think they have the Helm chart. Where I saw it, installer Helm. So you can install it here. I was looking through what was the things that I was deploying. So the CRDs, they have a V1 and they have some in V beta. So like the jobs are beta. And it looks like they just customize. These are for customize. So I don't know why they have the base. And then the templates. But we'll follow the instructions that they have. Okay, so this is done. -A. And then I should have 3 nodes or 2. Okay, so I have three nodes. A control plane, worker 1, worker 2, and nothing is running here. So if we do the instructions for the Helm, I think I already have it added, so it will complain, but we'll run it anyway. Yeah, it's already exist. If I run, what is it? Make this bigger, people see what I'm doing. Repo update, just to refresh what's the latest. And I can install the latest version, which is I think 1.9. So let's do that. So in reality, you don't have to like clone the repo. You can install the Helm chart either directly with Helm or GitOps. So let's see what got installed. So if we do get CRDs, usually that's what I inspect. See, we have queues, pod groups, NUMA topologies, which is related to NUMA, job templates, jobs, job flows, and commands. But from the documentation, I don't think people defines all of them. They work with the main 3 that we mentioned, like jobs, queues, and pod groups, and even pod groups get created automatically. So let's do what's next. So let's see if they have a hello world. This is just to check that everything is running. We can do that. I can check all the things that get deployed in here in this namespace. So it created 3 pods are running. This admission in it is basically, I think it's to configure the certs or upgrade CRDs if they're doing upgrades. They have 2 services. That mission is like mention webhook. The scheduler, probably that's a server that is running, which should be this one. Everything is deployment and replica set. And they have the job. Oh yeah, this is the job related to the complete think I'm doing better this time. Last time I was horrible last time with timing management. So that's running. And then that's it. It says after the configuration is complete, you can use Volcano to deploy AI, ML, and big data workloads. That sounds great. Let's go to the tutorial. Here's a simple example of how to use Volcano CRDs. So yeah, this is the kind. Remember, I was mentioning the example of the JAMA 2. Where was it? I think it was this is Ray, right? Ray is doing the training and it's creating Volcano jobs on that queue. But we saw that Ray was using Volcano, so was using a Volcano queue. So we'll be creating something similar like this, but we'll not do something like Hello World and GNX. I don't have time to show like the JAMA. Take some time. And let's go to the tutorial. So basically create a file called q.yaml with this information. So I'll copy this, create a file, q.yaml. I think I created one already. Let's see, example tutorial. This tutorial is not in the repo. I might just submit a PR with these files. Q, and then I don't know if I changed this one or not. I was playing with this. So 2 CPUs, right? That's the capability of the queue. So if you try to run more jobs that go beyond, those jobs are requesting more than 2 CPUs, then those jobs will not start. And I'm guessing if you are selecting the gang scheduling, then you're stuck because then that the gang scheduling is saying like wait for all the jobs to be running, do not start. But if you don't have enough capacity, I think say capability, maybe that's what is reflected as capacity that you want to give it. But anyway, you can put memory also. So let's create this. Where's this file? So I can do copy relative path and then do a k apply -f and then run it. And then let me see if it has instructions on how to see it. I usually like to see stuff when I create, so it doesn't have it here. So, but you can do k get, what is it, q. And notice this, that it says default and test. So Volcano, it looks like the Helm chart. When we deploy it, it creates a queue by default. So if you don't specify a queue in your job, it will use the default queue. That's kind of a nice thing to have. But usually when you are in production, right, you create multiple queues and assign the capabilities. So it has the test. If I want to see the details, I don't think there's much details here. YAML. And it will say the status, right? So it will say allocated 0, because nothing is allocated yet. I have not run any jobs. So there's not much information. If you do describe, you may get different information depending how they coded it. And it's a little bit easier to read, right, than the YAML. It depends if you like to read YAML or just like the describe. But you will get similar information. You may get more information in the describe if there's something in the controller that does that. And yeah, so 2 CPUs, very simple. I should have more than 2 CPUs. And then we'll do a job. So a job, you specify a name, you specify the minimum number of available ones is 1. The scheduler name, it looks like it's Volcano, so I'm guessing they're different schedulers. We'll look later to see if we can see the list of schedulers. Queue, you're going to specify one will be default, be test. And then the policies. If what happens when a pod gets evicted, do you want to restart that job? Or what do you want to handle those type of events? Task is how many replicas. So that is like the real work that is going to happen. It will have a section of the pod template, the template spec basically is a pod spec. So you can put here one container or multiple containers. So anything that you can put in a pod spec, you put it here. Then again, policies for the tasks, which is different from the policies for the job, is what do you want to happen when this event kicks task is completed, right? The action is complete the job when all the tasks are completed. So let's run it. And yeah, the thing is, like, this file was not in the repo, so I needed to create it. So I think I already created it. Job. So here's a job. I think I was playing with this job the other day. So let's name it one, or maybe just copy paste what's here, which is one job, and then we'll start switching numbers, see what happens. Any questions? I have not looked at the chat. No, there's no questions. I think everybody's like silently following along. So here's a job. This job is going to be an image. I'm going to use nginx, basically just do a sleep just for testing purposes, right? It's a tutorial, so it's going to sleep for 10 minutes, right? Jobs can take longer if you're like training Llama, for example, take hours, or large language model. And then how much, like every time you specify a pod in Kubernetes, you have to, I tell people this again and again, you have to specify the requests, uh, uh, or not even limits, but the requests, like an idea of how many CPUs do we need for it. Usually limits something that you can like remove. Usually you don't need it. But request is like something that is like, because that's how we know if we're going to relaunch 10 or 15 pods for this job, then we know if we will fit in the queue or not. So I'm guessing the queue will use resources, hopefully not the limit. And then do not restart, right? So this is the thing of like, this is similar as a job by default. If like the container runs and then stops, like there's no restarting. Normally in Kubernetes, when you create a deployment, it gets restarted. So let's run this guy, or this file, sorry. Copy relative path. Okay, apply -f, run that job, and then I want to see what's up with this job, which I think that's the next thing that they have in here. So you want to see what's happening with this job, and you can see the YAML or the describe. We'll do both. We move this up. So same spec information that we did before. That's same exactly, but then the important part is on the conditions. So it says spending, and then it was running. So that's the conditions: minimum available 1, running 1. So why it says running 1? Because in the replicas we set replicas 1, right? But you can put this to 100, that you want 100 pods to be launched. So we'll do that in a second. And then phase, they're running. So that's the state that the queue. So in terms of the queue status for this task, it will know that information. So if we do, I think we can describe get queue and not get the YAML. Let me see if I get. It'll give us. I know what's going on. There's this. So as you can see, there's no really like good way of like getting this information, right? So you look in the queue, and you say in the queue like allocated is one pod is running, allocated, right? Allocate one pod. The CPU is 1, so that's what it's being consumed, and then running is 1, and the state is open. They have a tool called VCC Volcano CTL or control to make it a little bit easier. So if we want to use that, I think they have the release. I don't know if they have the release. I'll compile it. So let's check if they have the CLI here. They don't have. So that's something also you can help in docs, like in the installation, have a section on how do I install the CLI, VCCTL. Remember that we saw it in the architecture. there's VCCTL, and then I was like, where do I get it? Um, so let's see if it's attached in the release. So 1.9, and see if there's a binary. Where is the binary? No binaries. Interesting. I bet there's going to be brew, but I don't like to personally don't like to download any binary from the internet and run it. Not that I don't trust people, but you can compile it. So I was able to compile it. It has a make file. So here's a make file, and I was looking for the VCCTL, and VCTL is here, so it's part of all. So I was able to do make all, right? Or I can just like run VCTL. But there's other, yeah, you can do make all, or you can run VCCTL, and it will use Go. So I think I mentioned that they use Go. These are Go controllers. So the CLI is also a Go. So it's compiling the CMD CLI folder. The output is this binary in this directory, and then this directory is this directory here, output bin. So if we check output bin, let's see, we have it, and I have to compile it. This will be ARM64. I'm using a Mac, which is v64. So that's VCCTL. If we want to run it, usually I like to put it in my path. So let me do export path, and then VCCTL. Let me see if TL, too many T's, VCCTL. Yeah. So now I can see, I can do things with the job template, and the queue. So I bet I can do queues, right? And I can do for a queue, I can create a queue, delete a queue, get a queue, list a queue, and operate a queue. Create and delete, I think from the CLI is okay. For hacking, for like Kubernetes, it's better to do things like in YAML and then GitOps. But the get and list is useful. So if we do list, we'll see that we have queue. Wait a minute. Put it at the top so people can see it. And that's not the command that I want. BCC. Yeah. So see, this is better information. This is the same information that is in the status of that CR, custom resource, Kubernetes resource. But yeah, if you are writing an API, then you talk to the Kube API, get that information. But if you're like human and running the CLI, then it's better to use this CLI than kubectl. They could potentially add and we can do it. I don't think we'll run out of time. We can add this CLI as a kubectl plugin, basically like adding kubectl dash VCCTL into bin, and then you'll be able to do kubectl. Let me see if I can do that, and then instead of explaining it, so you can copy output this guy into somewhere. Let's copy to the same place, bin. Let's see if this will work. I don't know if this will work. VCCTL, and then you'll be able to do kubectl VCCTL, and it's the same thing. This is a better user experience, right? You can then distribute the plugin with we have a community Kubernetes CLI project to distribute. Just I cannot remember the name now. Cube, I cannot remember the name. Sorry. But yeah, you can do now kubectl. Actually, now it's if you like kubectl in front of it. So we can do also get. I think it was test. Oh, it's mandatory. So you will do dash help. I think it's n maybe. Dash n test. And it's the same thing. Right. So it's open and it's still running because we put 10 minutes, right? If we want to see the pods, then we can do get pods. And you see that that nginx is running. And that nginx was asking for one CPU, but what about if and basically that's the tutorial. So let's go back to the tutorial. It says create a queue, create a job, get the status of the job, um, and get the pod group, like get the status of the pod group, job one. So a pod group was created. So let's do that. Let me see. You can also do um, in here. I was going to say you can. We also can do the VCCTL job. What's it? Job view. Let me see if it gives us the information about the group. Dash and what was the name of that job? VC job one, I think it was. Maybe this one, I think. Yeah, there you go. So you get kind of the same information that it's a kubectl YAML. So that basically did a describe. This is the output of doing a describe. So for example, if I do k describe vc job one, it's the same output. So the CLI didn't give me more information than that, but a group was created. What's the group? A group was pod group, right? So we created a pod group with the same job name. So if I do k describe pod group, actually no, you have to specify the name, right? The whole name, specific name, and then you get the information around like the specification for this pod group, which it says it's using the Q test. The task name is called nginx. That's how we call it, and then is the number of pods, CPU, and request CPU. So how many? So yeah, I was asking earlier if it was because using limit or request doesn't make any sense to make the limit is like request. You can also ask request for memory. So you have a memory intensive jobs and you want certain amount of memory request, then you put it here and then it will show us minimum, right? I'm guessing. I think I saw memory in one of the examples. So it's running. I think it's still running. Let me see. Get pod /a. It's still running. So what happens if I create the queue? We saw only accepts 2 CPUs. The job is asking for one pod, one replica, one CPU. So I still have space for one CPU. So I can name this one 2, and I'm going to add for 2 CPUs. One is already running. So what would happen? I don't know if people want to guess in the chat. Would it run? Would I have 3 pods? Oh, this one is almost done. Let me. If it dies, I will run it again. Like let's call it. I put it back. I think this is almost done. And then we'll do the scenario I was trying to describe. Let me see, get pods. And yeah, so it's completed. So the pod will not go away, right? The pod stop running, is completed. It should not be deleted because this is how you're going to get the logs out, right? So if you do get logs, what's the name of this thing? Job. There's no logs. I think this is nginx. So it's gone. But anyway, if we start this guy again, I think it would not do anything. So let's create 2, add for 1 CPU, and then we'll add another job 3 and add for, or maybe I just delete this one. Let me delete it. Okay, delete. What is it? VC job 1 is deleted. I'm going to create it using the same file, something like that. Okay, apply. I thought I copy pasted. Copy relative path. Come on. Yeah. So now I have new pods. Or I can just do, I don't know why I list every pod. It's running. If I do vcctl q, come on, you can do it. I can do list, right? 1 running, 0 pending, 0 in queue. And now let's see that I want to create a new job. job 2, I'm going to send it like, I don't know, 5 replicas of nginx. I want each one asking for 1 CPU. Let's see what happens. Anyone wants to guess in the chat? Or maybe Jorge? I think we're going to get one more pod in there, because I'll have space for 1 CPU in the queue. So let's give it a try. So I'm asking for 5 pods. Copy, relative. Oh, I saw someone. I think you will get 1. Cool. Thank you, Jorge. Usually this is the type of stuff I also do in the Kubernetes book club that I run on Fridays. We hack on examples, and then I ask people, which I don't know, they don't know, I might know. So that's how we learn Kubernetes, right? Sometimes it might be a bug in the software. So let's run it. Okay, apply -f. And then now I have, let's list the queue. And now 2 are running. There's no pending because I added, so k get pods -get pods. Look at that. So everything's running, and each one is asking for CPU. And anyone wants to guess why they're pending? So they're created but pending. So actually, yeah, I my bad. I saw many pods and I got so excited. I've seen so many pods that I thought all of them were running, but actually 2 are running. We have 1, 2, 3, 4 are pending. For some reason, I was expecting to see here pending in the queue, but it's not there. Let me double check. No, it's not there. I don't know if it's a bug in the software or that's supposed to be like that, which again, better documentation may have the answer, might not. We didn't have time to check the documentation, but that's the next thing. But it's working as designed, right? I don't have more CPUs. I have more CPUs in these worker nodes, because if I do describe node, right, I can do pipe that grep, and I can do CPU, and I have 12 CPUs. This is a big computer that I have. So each node has 12 CPUs. So I have enough CPUs. So it's not pending for that reason. It must be pending for another reason. So anyone wants to guess? So if you don't know, let's find out. So let's take a look. Describe one of these guys. Describe one of these pods. Sorry. Describe pod, one of them, and there should be an event, right? That will tell us like why is this thing pending. And it's saying is not available because all nodes are unavailable, meaning because of the queue, not because I don't have enough CPUs available, so that it will not schedule it. And then the other thing that we can take a look is, let me see if it's here or not. Have a container. This is a pod. I'm describing a pod, and that is pending. I was looking to see if the scheduler is different than the default scheduler. Interesting project. But yeah, fail scheduling from Volcano. So who's Volcano? Want to guess? Volcano is the scheduler. So he went to the scheduler of Volcano. I was expecting to see the override of the scheduler, but maybe it's not in the YAML. Let me see if it's in the YAML. A few minutes left. -o YAML grep -I schedule. Found it. See, Kubernetes is not magic. Everything is there. So let me explain a little bit what's going on. So in a Kubernetes, if you don't specify custom Kubernetes scheduler to place pods in nodes and have them like in state of running, it will be the scheduler is basically default. The name is the default scheduler. or you can put an alternate scheduler. In this case, Volcano is implementing a scheduler, but in your pods or deployments or whatever is the abstraction you're doing, but at the end of the day, it's the pod. There's a field called scheduler name, and the scheduler name, if I can find it, spec scheduler name. Blind. Give me a second. Pod reference spec scheduler name. I bet everybody in there was watching or watching the recording say, "It's right there. You're blind." It says scheduler name. It says Volcano. So there's a scheduler registered in Kubernetes called Volcano, and then these pods, I want to be scheduled by the Volcano scheduler. It will go to Volcano, and since the queue, this job is associated to that queue, and queue only has the capability or capacity of 2 CPUs. I ask too many, the other ones are just pending. This is the value of Volcano. Wanted to get to, right? These are the type of things, and then this is using one type of schedule algorithm. They have, I think we saw like 7 more type of different schedule algorithm. This is why people use Volcano, because they don't want to re-implement this type of, you know, basic scheduling of pods. So a lot of all these projects like Ray and PyTorch and all these things, basically on top of Volcano, they can get the benefit of using Kubernetes for this type of scheduling jobs or pods, right? At the end of the day, it's a pod or containers. Um, and we have any questions? I think we're almost at the end. I think we're 1 hour, right, Jorge? 3 minutes left. Okay. Let me see if we can show one more thing. So we got the prod group.
Yeah, you have 2 minutes.
Okay. We have the test, which we saw the queue, but this tutorial could be updated with the VCCTL, right? That could be improved. And I think that's it. But yeah, the concepts are queues. You create queues where you have like maybe real scenarios that they can come up with. I've seen in the past, not necessarily Volcano, but in Kubernetes, where people want to have queues that are like high priority. Like if something comes in, I want to like process this and skip the line, right? And then they have you create 2 queues, one lower priority, one high priority. So maybe a company is like processing checks once a month. So they want to make sure that when checks are coming in and maybe the Kubernetes cluster is being used for something else, maybe this was the time where we didn't have like autoscalers for nodes. It was sent to one queue versus another queue, or you have 2 departments, or whatever how you want to share a Kubernetes cluster. A Kubernetes cluster is kind of your cloud of resources, and then the pods are like executions. So it's a matter of like how do you want to manage these pods that they need they need to wait for something, maybe other pods, or they need to skip the line, or like pod like do not process these pods because there's more important pods in there. So that's the queue. And then the job is the way that you describe like the tasks, like what is the container, like the Python program, the PyTorch program that you want to run to either like train a machine model in terms of distributed computing. And yeah, the ecosystem, these are popular projects. Flink, very popular. Lately I've been working with customers and end users on Flink. Kubeflow, always there's customers and users running this. MPI, in terms of like government and people are doing HPC. I was mentioning, right? HPC is using MPI for that communication. So using like Slurm, or this new project coming out, Sunk, which is Slurm on Kubernetes, we'll be using something like this, MPI. TensorFlow, very popular in terms of machine learning and AI. Spark for distributing, if you want to write things in Python or R, very popular. Also for like high-level Scala and Java APIs. That's a great combination. So it's combining Volcano with one of these tools in the ecosystem. And then the schedulers. I mentioned there was a schedulers. The scheduler, how it works. So this requires maybe a second part. Somebody else wants to do a second part on deep dive, but I just wanted to do an intro of Volcano, how to get it started, running in Kubernetes, maybe in kind, knowing the basic CRDs, and then you can get involved into the project. If you want to contribute to Volcano, I bet those maintainers are going to be happy to have you like help maybe getting started with the documentation, or maybe a video on showing how to use it. Oh, here's the CLI. So the CLI is here, and the way you get the CLIs we make. I think that's it. All right, what do you think? Did you learn something about Volcano?
Definitely. Yeah, this one I hear a lot. We talk about this one when we do talks at AI.dev, because a lot of
Yep.
people using Volcano. So like, it's definitely one of the projects that's getting a lot of shine or an attention. So hopefully y'all got your tour here. Jack has a question here. I'm just going to go ahead. Before we finish, what use case was Volcano invented for? 1, AI training inference. 2, classic IT application batch scheduling, or recreating an AWS GCP for fee service, or other?
I think all of the above. Like, yeah, many use cases, right? In terms of creating jobs. But it's mainly was created for that Kubernetes interface, right? Abstraction. Like, these are
Mhm.
type of things that they get created, and type of use cases that you don't want to put in Kubernetes core like right away, right? So that's why there's also a working group, batch working group with many
Yeah.
companies and end users, like trying to know, like, are these things that belong in Kubernetes or not? And I think that questions is less relevant today, because now there's ecosystem of extensibility of Kubernetes. So we're moving in the opposite direction, right? That the
Mhm.
ecosystem can build their own extensions, their own CRDs, and then it's up to the community to come together like, hey, let's not reinvent the wheel 5 times. Let's create one. And Volcano is very, like, from what I see, like the last, I don't know, 2 days since I've been playing Volcano, right? I'm not an expert. It's a basic building blocks. And that's a good thing. Like, if it gets more complex than that, to try to do everything, like do the training on machine learning, to do the batch processing, high level scheduling, then it gets too complicated, then it doesn't serve the purpose of being a base building block. So I think it's a good way of like building abstractions over abstractions.
Mhm. All right, and that's all we have this week. Thanks everyone for joining in. Next week we are looking at Score, which is a workload specification. So this one should be rather interesting. I
Yeah, every
can't
week
wait
we
to
want to
see.
have something here. Yep,
Yeah, we are.
something new.
All right, Carlos. Thanks. I think we have you coming back here relatively soon. Here, I
Yeah,
don't have the spreadsheet in, and we need to get that GitHub repo all sorted.
we'll
Like
be
I told everybody.
surprised. Yeah, I like this, Bryce. I like to learn the fly. But the good thing is, like, that's a way that you can maintain your Kubernetes skills, right? That doesn't change. Kubernetes is not magic. Like what
Yeah,
we saw, right? We figure out like where the scheduler was coming from.
yeah, for sure. All right, with that, everybody, have a great day. Stay safe out there.